Time travel? Few ideas have captured the human imagination more powerfully. From ancient myths to Hollywood blockbusters, we dream of visiting the past, witnessing the future, or escaping the present. But here's the big question. Is it just fantasy, or could science actually make time travel possible? Today we'll dive deep into the wildest theories of physics, from Einstein's relativity to quantum mechanics, from paradoxes to wormholes, and explore what the future of time travel might really hold. Long before physics textbooks, humanity told stories of moving through time. Ancient Hindu texts describe the story of King Kakudmi, who visited a god and returned to find centuries had passed. In medieval Japan, tales spoke of Urashima Taro, who spent a few days in an undersea palace, only to return and discover 300 years gone. Even in the West, legends of prophets and sleepers in caves echo the same theme. Time flows differently in different realms. These myths suggest a deep intuition. Maybe time isn't as rigid as we think. For centuries, time was thought to be absolute. Newton's universe treated it as a universal stage, ticking at the same rate for everyone. But in 1905, Albert Einstein shattered this illusion with special relativity. The speed of light, Einstein realized, is constant for all observers. To preserve this law, space and time must stretch and bend. The result? Time dilation. Moving clocks tick slower. And 10 years later, general relativity revealed that gravity itself also bends time. A clock on Earth's surface runs slower than one in orbit. Near a black hole, time may slow almost to a stop. Einstein didn't mean to invent time travel, but relativity showed that time isn't universal. It's flexible. It's relative. And that's the first crack in the wall. Here's the mind-blowing part. We already know how to travel into the future. High speeds. Move close to the speed of light, and your clock slows down. A one-year journey for you might equal decades for people on Earth. This is the twin paradox in action. Strong gravity. Sit near a massive object, say a black hole, and your clock runs slower compared to someone far away. We've tested this. Astronauts aboard the International Space Station actually age a little slower than us. It's tiny, milliseconds, but it's real. So future travel? Absolutely possible. We're doing it right now, just on small scales. But what about traveling backward in time? That's where things get messy. Physics doesn't outright forbid it. Equations of relativity allow for closed time-like curves, loops in space-time where you could, in principle, end up in your own past. But traveling backward raises paradoxes. The grandfather paradox. If you went back and prevented your grandparents from meeting, would you erase yourself? Causal loops. What if you give Shakespeare a copy of Hamlet and he publishes it? Who really wrote it? Backward time travel is theoretically fascinating, but logically explosive. One of Einstein's predictions are wormholes, or Einstein-Rosen bridges. Imagine space-time as a fabric. A wormhole is a tunnel connecting two distant points. If one mouth of a wormhole experiences time differently, say near a black hole, or accelerated close to light speed, then traveling through could, in theory, allow you to step into the past or future. Physicist Kip Thorne and others explored this idea seriously in the 1980s. It even inspired Interstellar. But there's a catch. Wormholes might collapse instantly, or require exotic matter with negative energy to stay open. That's something we haven't discovered yet. Other exotic ideas for time travel include cosmic strings, hypothetical 1D defects in space-time, thinner than an atom, but infinitely long with immense mass. Two moving past each other could, in theory, create closed time-like curves. Tipler cylinders. Imagine an infinitely long rotating cylinder of dense matter. Frame dragging around it might allow backward time travel. Sadly, infinite cylinders don't seem realistic. These ideas show that physics isn't allergic to time travel. It's just very, very demanding. Relativity isn't the only game in town. Quantum mechanics opens stranger doors. Quantum tunneling. Particles can appear across barriers instantaneously, as if ignoring time. Retrocausality. Some interpretations suggest effects might influence causes at the quantum scale. Many worlds interpretation. Perhaps traveling to the past doesn't change our history. It just branches you into another timeline. Kill your grandfather there, and you're still alive here. In quantum physics, time is less a straight arrow and more a fog of probabilities. Every time travel theory crashes into paradoxes. But scientists and philosophers have offered possible escapes. Consistency principle, Novikov. Events are self-consistent. Even if you travel back, you can't change history. Your actions were always part of it. Multiverse theory. Every change spawns a new branch. No paradox, just infinite timelines. Chronology protection. Hawking. Maybe the laws of physics themselves forbid backward travel, closing the loopholes before paradoxes occur. So far, the universe hasn't let us break causality, but the jury is still out. Has anyone ever seen evidence of time travel? Particle accelerators. We've pushed particles near light speed. They experience slowed time, but not backward time. Quantum experiments. Some results hint at retrocausality, but nothing conclusive. Time travelers among us? Physicist Stephen Hawking once hosted a time travelers party, sending invites only after it happened. Nobody showed up. So far, no DeLorean has arrived from the future. Could we ever build a time machine? Future travel guaranteed. High speeds and gravity wells do it naturally. Backward travel requires exotic matter, cosmic engineering, or quantum breakthroughs. Not impossible, but far beyond today's tech. Some theorists suggest that if backward travel is possible, it may only be possible once we create the machine. In other words, no visitors from the past, but future generations could visit us. Time travel isn't just about sci-fi fantasies. Exploring it sharpens our understanding of space-time itself. Causality and free will. The limits of physics. And it inspires real technology. Remember, relativity once sounded insane. Today, it's why your GPS works. Quantum mechanics sounded like magic. Today, it powers computers and MRI machines. Who's to say time travel won't follow the same path? Is time travel possible? In one sense, yes. We're all traveling forward at 1 second per second. With relativity, we can jump into the future. With quantum mechanics, the past may not be as fixed as we think. Backward time travel? It remains the wild frontier, perched on the edge of science, philosophy, and imagination. But here's the real wonder. Even if we never build a time machine, the search itself is reshaping how we see reality. And maybe that's the greatest journey of all. If you could time travel, forward or backward, where would you go and why? Tell us in the comments below. And don't forget to subscribe for more deep dives into the strangest, craziest frontiers of science.